give you an example. So let's say if you have elements present at 26, 72, 60, 56, 10. Are you getting me? So let's say into this, which are elements which is present, you are interested in searching 26, correct? So when you're starting from the first element itself, right? So the best case is going to be search element 26. Makes sense? Because this is the best case. Whatever you're desiring, you're getting that into the very first flow itself. Are you getting my point? Satyam, can you recall this thing? This is what I stated, right? Let's say you're interested in Microsoft. So this is the best case. You're interested in Microsoft's interview. The very first interview which you gave without any practice, you got the job offer. So that is the best case. Are you guys able to follow this example? Anyone having any doubt? So the very first try that you are doing, you are successful in that. That is the example of best case. Now let's talk about the average case. The average case, as the name suggests, right? It is in between the best case and the worst case. So best case will be the search element 26. Why? Because in the first iteration itself, you are able to find out element number 26. In average case, what is going to happen is, let's say you are interested in searching 60. So in average case, if you will notice, right, searching element 60, it is neither the best case nor it falls under the category of worst case. It is falling in between. So this is about the average case. Now let's talk about the worst case. It will be when you are trying to search 82. Why 82? Because what will happen? It will search for 26. Is 26 equal to 82? No. Is 72 equal to 82? No. Is 60 equal to 82? No. Is 56 equal to 82? No. Is 10 equal to 82? No. So in the worst case, what is going to happen is you are searching each and every element into the array, right? But still that element is not present. So in the worst case, you have iterated all the elements which is there. So let me just give you an example, real world example. Let's say you have 5 companies, C1, C2, C3, C4, C5, for which the interviews has been lined up. So what is going to be the worst case situation? That you are rejected from C1, you are rejected from C2, you are rejected from C3, you are rejected from C4, you are rejected from C5. So in the worst case scenario will be you have not landed in any job interview. Correct? So that is going to be the worst case scenario. What is going to be the best case scenario? Let's say C1, and C1 is your dream company. So in the very first company, you have got the job offer. Correct? So that is going to be your best case scenario. And what is going to be the average case? Let's say you are getting picked up by C3 after giving 3 rounds of interviews, because you got rejected from C1, you got rejected from C2, and this is your 3rd round of interview in C3 and you got selected. So that is going to be your average case. So is this part clear to each and every one of you? What does best case, average case, and the worst case means? Are you guys able to correlate with the real world example which I used to explain the concept to you?
Yes, Sanjay.
Anyone having any doubt or concern till this point? Feel free to ask me in case anyone has any doubt or concern. Okay, so it's looked like it's clear to each and every one of you. That sounds wonderful. But still, let me begin a counter before proceeding ahead. In case anyone has any doubt, feel free to stop me. Tick, tick one.
Sorry, excuse me, Ranjan. I have one question.
Yeah. Yeah.
So generally, when we are talking about these asymptotic notations and this time complexities, we are always considering the worst case scenarios, right?
Yes. Yes.
Then what is the benefit of having best case and average case? Like, are there like any scenarios where we are like taking use of this, or it is always the worst case that will be of use to us?
See, the thing is that what happens is if you see from the software engineering world's point of view, right? So let's say you are trying to build a WhatsApp. So in the WhatsApp, when you're trying to build your application, right, like WhatsApp, correct? So in that case, you will think of worst case situation. Let's say during Happy New Year or during Diwali, everyone will bombard your app with hell lot of messages. Getting me? As a result of which, your system or the microservices architecture, right, it will be at its peak. It will get a huge amount of requests. So you are trying to build a system since you are trying to make your system available, fault tolerant, right? So you will think of the worst case situation where that, okay, in this worst case situation, you need to make your system available. Getting my point? Best case situation, obviously, or if in the worst case, your system will be available. So obviously, if no one is going to use WhatsApp, your system is going to remain available, right? It is not going to break down. So this is where worst case comes into the picture, that no matter how much worse the situation is, but still you are able to handle the request, or you are still having your system available, which helps in having a great user experience. So that is why in normal software engineering world, the interviewer he will not mostly he will always be focused about the worst case itself. And the best case is nothing but, yeah, again, since you are obviously analyzing about what is the worst case, the best case and average case, it's like you can say that, okay, this is the best case, this is the average case, but in real world, obviously, you will think about the worst case, and thinking about the worst case, you are going to come up with some design, right, to make sure that your system is available and it is fault tolerant during that time, and it should be scalable as well to handle those much amount of requests, right? So that's why the worst case scenario is taken into the picture.
Yes, got it. Thank you.
Anyone having any more doubts or concerns? Okay, so I'm taking that as a no, but still I'm making a counter. In case anyone has any doubt, feel free to stop me. Tick one, tick two, tick three, tick four, tick five. Okay, sounds good. That's wonderful. So yeah, so this is about the best case, average case, and the worst case. So let's say you have got an array of elements. And if in case anyone doesn't know what an array is, I'm going to explain about array when I'm going to start the array data structure. But as of now, just assume that array is contiguous block of elements. You can just assume that array stores the same elements, right, in the contiguous block of memory. That's it. Because whenever you are storing any number, obviously it is going to get stored into the memory, right? Let's say the starting address is going to be 2000. The next element where it is getting stored, the memory address is going to be 2004. If that element is of size 4 byte, next element is going to be 2008, next element is going to be 2012, next element is going to be 2016, correct? So if you can see, the array elements are getting stored in the contiguous memory location. This is 21. This is what? This is called array element. 21 is array element. 31, 41, 51, 27. So these are the array elements and these are the memory address. So in case of array, the elements are stored in contiguous memory location. This is the property of array. So let's say the size of the array is n. In that case, you are trying to write an algorithm to search a specific element. So how you are going to write an element? You are going to have for int I is equal to 0, I less than n, I plus plus. And then what you are going to do? You are going to check if arri equals to target. If that is equals to target, let's say you are going to return the index element I, correct? And let's say if you are returning in the end, that means you will return -1, stating that you have not found out the target element. Is everyone familiar with for loop? Anyone who is not familiar with the for loop, you can let me know. I can explain you that also. Is here anyone who is not familiar with what a for loop is? If in case is not familiar, don't be hesitant. You can feel free to ask me. I can explain you that also. Okay, so it looks like everyone is familiar with for loop. That sounds wonderful. But still, in case anyone is not familiar, I is nothing but the initialization. I is equal to 0. I less than n is nothing but the conditional variable. For loop needs to be satisfied. For loop, it will go inside the for loop only when this condition I less than n is getting satisfied. And I plus plus is nothing but increment. It is incrementing the value of I. After incrementing, it is checking if this condition is true. If this condition is true, then it is coming inside the for loop. Now, what you are doing, let's say you are trying to search 68. That is the target element. It will start with I is equal to 0. You will check 0 less than n. What is n over here? What is the size of the array? It is 5, right? You will say that yes, 0 is less than 5. What you will do, you will check is 21 is equal to 69? No. After that, what it will do? It will do I plus plus. Now, what will be the value of I? The value of I will be equal to 1. It will check is 1 less than 5? You will say that yes, 1 is less than 5. The condition is true. It will check is 31 is equal to 68? No. Again, it will do I plus plus. I is equal to 2 now. This is the index 0, 1, 2, 3, 4. Now what it is going to do? It will check I is equal to 3. I is equal to 2. It will check if ARR 2. What is the ARR 2? 41. Is 41 is equal to 68? No, it is not the case. Now it will do I plus plus. What will be the value of I now? It will be 3. Is 3 less than 5? Yes, that is correct. It will check is 51 is equal to target? No. Now what we will do? I plus plus. The value of I becomes 4 now. What it is going to do? I less than n. 4 less than 5. Yes, this condition is true. It will check if 27 is equal to 68. No. What it will do? I plus plus. I will be equal to 5 now. So is 5 less than 5? No, 5 is not less than 5. So what it will do? It will return -1. So you guys can notice, right, that in the worst case, it is traversing the entire array, correct? It is traversing entire array. What is the size of the array? It is n, right? So that is why the time complexity will be big O of n. The worst case is denoted by big O of, it is denoted by big O notation. That is why the time complexity is big O of n in the worst case. Why? This is because it has iterated the complete array in the worst case. And time complexity will always be a function of n, where n is going to be the size of the array, or n is going to be the size of the tree, n is going to be the size of the linked list. Depending on the data structure you are going to use, n will be nothing but n represents the size of that data structure. Is this thing clear to each and every one of you? Anyone having any slightest amount of doubt? Feel free to ask me. Yeah, it's clear to each and every one of you till here.
Yes, sir. It's clear from us.
Perfect. That looks good. So yeah, this is about the time complexity in case of an array in the worst case. So now, once this part is clear to each and every one of you, now let's move to the linked list. So I'm going to discuss the time complexity for the different data structures, right? And then whenever we'll be covering the data structure, you guys can easily figure it out that, okay, what is going to be the time complexity for this question. Similarly, if you have got linked list, I'm going to explain about this data structure, no worries. But as of now, you can just assume linked list consists of node, where node has the data part as well as the address part. Each node has the data part as well as the address part. Now in the linked list case, can you guys tell me what is going to be the worst case of searching any element or doing any operation over here again for the linked list part?
Order of n.
Yes, it is going to be big O of n only. Why? This is because in the worst case, you need to traverse the complete linked list. Does this thing make sense to each and every one of you?
Yes.
Anyone having any doubt? So this is regarding the linked list. Now, similarly, in case of binary tree, what happens is, let's say you've got 31, you've got 40, you've got 20, you've got 60, you've got 2, 8, 31. If you are trying to search any element in the binary tree, and total number of nodes is n nodes is present into the binary tree. So I think you guys can easily extrapolate now, right? What is going to be the time complexity in doing any operation in the binary tree?
Log n.
Log n. Are you sure? There's a difference between binary tree and binary search tree.
2 power n.
Order of n. Order of n only. If it is left skewed and right skewed with it.
Sorry, one by one.
So it will be order of n if the tree is left skewed tree or right skewed tree. So it will
No,
traverse.
if let's say if it is not left skew tree or right skew tree, in that case, let's say I'm interested in searching in this tree, whatever you have got, right? Is this a skew tree?
No, it's
It's
full
not
tree.
a skew tree, right?
Yeah.
I'm going to discuss about them. Don't worry. If in case anyone has any doubt about what a skew tree, don't worry. I'm going to explain them in the binary tree while I'll be covering that. But as of now, let's say you're interested in searching 100 over here. You will start with, let's say, 31, then you will go to 40, then you will go to 60, then you will go to 2, then you will go to 20, then you will go to 8, then you will go to 31. That means you have traversed each and every node. Did you get 100? Node number 100? No,
No.
right?
No.
So how many nodes did you travel? 1, 2, 3, 4, 5, 6, 7. You traversed total 7 nodes. And what is the value of n? N is equal to 7, right? So what is the worst case time complexity over here? Can you think?
Order of
Big
n.
of order of n.
It's big of n, right? So can you guys see? Can you guys see the pattern again over here? That's how it is coming out to be big of n. Did you guys notice this trick? Anyone having any difficulty here?
No, Ranjan.
So the thing is that the basic crux over here is that you need to traverse each and every node. Just like in array, you traverse each and every element. Just like in linked list, you need to traverse each and every node. Similarly, in binary tree also, you are traversing each and every node. That is why in the worst case, the time complexity is big O of n. Don't worry, how we are going to traverse in the binary tree, I'm going to explain that trick. Don't worry about that. But as of now, try to understand in terms of time complexity.
Ranjan, I have a question here.
Yeah.
So what I have understanding from binary tree is that left side they have a smaller number and the right side they have a bigger number.
That is a property of binary search tree, not binary tree. Binary tree doesn't have any such property.
Oh,
The property of binary tree is that it can have at max 2 children. That's it. That is the only property of binary tree.
okay, got it.
Is this the example of binary search tree? No, right? Because 21 is obviously less than 31. Does this thing make sense to you?
Yes, ma'am.
Anyone having any more doubts or concerns? Feel free to ask me.
Ranjan, when you told like binary tree has two children, it means the top two children, right? Not the leaves also.
So yeah, let me explain. Don't worry, I'm going to explain in binary tree in depth. But any node can have two children, as in this is the node which you have got, right? It
Okay.
is going to have the first children. It is going to have a second children, correct? Now
Okay.
this is a new node which you have got. It is going to have left children. It is going to have right children at max. This is the new node which you have got. This can have either the left children or right children or both. So
Okay.
each and every node can have at max 2 children. That's it.
Okay.
Let's say this, and this, correct? So this node
Okay.
can have at max 2 children. It cannot have, let's say, 3 children, right? This
Okay.
violates the property of binary tree.
Okay.
So
Okay.
any node can have only at max 2 children. That's it.
Okay. Got it, Ranjan. Thanks.
Anyone having any more doubts or concerns? When being a counter, in case anyone has any doubt or concern, feel free to ask me. Tick 1, tick 2, tick 3, tick 4, tick 5. Okay, sounds good. Now let's take an example of binary search tree. Binary search tree has property that root value, as one of you pointed out, is greater than left child value and root value is less than right child value, correct? Let's say you have got 100 over here. So obviously left child can have only less than value 100, less than you have 50. Let's say you have 150 over here. let's say 125, you have 175. Over here you have 25, you have got 35. So this is an example of binary search tree, because binary search tree has this property that left child value is less than root value and root value is less than right child value, correct? So if you will notice over here, what you will notice over here, if you will notice over here, let's say you're interested in searching 75 in this binary search tree, correct? So now the thing is that what you are going to do, you are going to compare 75 with root node value, correct? You will check that, okay, if 75 is less than 100, so now you know that it is present into the left subhalf of the tree. Why? This is because 75 is less than 100. Are you guys able to follow this point? As 75 is less than 100, so it is going to come into the left subtree. Makes sense? Now the thing is that now you are into the left subtree. Now you are coming to 50. So you will check that, okay, is 75 less than 50? No. Since 75 is greater than 50, so where will you go? You will go to the right subtree. Now when you're going to the right subtree, you're comparing, okay, 75, it is equals to 75, return that value. So you will notice one thing, that at each and every node, you have two options, either go left or go right into the binary search tree. So as a result of which, the recursive function which you get is Tn by 2. Why Tn by 2? As I stated, at each and every node, you have two options, either go left or right, correct? So you are only focusing on one specific subtree, not both, plus 1. Why 1? Because you are searching for that root node value and comparing that root node value with the target. If both of them are same or not. If not same, that is why check with the left subtree or right subtree value depending on the value that is greater than or it is less than. And if you will notice using Master's theorem, since it is Tn by 2 plus 1, you guys can solve using Master's theorem. There's a Master's theorem to solve recursive function. You will get the time complexity as big O of log n to the base 2. That is the worst case time complexity for a binary tree. Let's say you have got tertiary tree. So at each and every node, you would have got three options, either go left or go middle or to the right. So in that case, what would have been the time complexity? It would have been Tn by 3 plus 1. So what would be the time complexity? We go of log n to the base 3 n. So whatever will be the denominator, make that as 3 and n becomes n over here. Case of tertiary tree. Is this thing clear to each and every one of you? That why in case of binary search tree? See, in case of binary search tree, we are not going to search each and every node. Why? This is because depending on the node's value, we are either going to search into the left subtree or the right subtree. As a result of which, at each and every node, your search keeps on getting reduced by half of the size of the array. That is why it becomes Tn by 2 at each and every part. That is why you get this recursive function Tn is equal to Tn by 2 plus 1. Does this thing make sense to each and every one of you?
And then
Uh,
what is the difference between that big O of on the n on what's it, the T of n, right? This didn't come for the last two arrays or linked list, but here we have this notation called T of n. What's the difference between this and the big O of n?
See, this T, it is used to denote recursive function. It is nothing but a functional representation. Remember in mathematics, we had learned function. Let me explain you that. So what is a recursive function? A recursive function is a function which calls same function again and again, f of n. Remember in mathematics in class 12, you might have remember fx is equal to x cube. Remember this thing, algebraic function.
Yeah.
Remember? Let's say x cube plus x square plus 3x plus 1. This is the thing which we used to integrate, differentiate, right?
Yeah.
So whatever will be the highest power of x, that is going to be, let's say you're having x cube over here, right? Since x cube is going to dominate over x square plus 3x plus 1. So what will be your time complexity? It will be big O of x cube. Are you getting my point? In this case, in terms of time complexity, we replace fx with fn. Why? This is because n is the size of the array. In general convention, right? So you have n cube plus n square plus 3n plus 1. So what is the most dominating out of this? N cube is most dominating, right? So that is why in the worst case, your time complexity will be big O of n cube. You ignore the rest of the things, correct? So this is how you are getting big O of notation. Because let's say the value of n is equals to 4 over here. So out of this equation, which is having the maximum value? Obviously 4 to the power 3 will have maximum value as compared to 4 square, correct? So that is why you are considering that value which is maximum in the worst case, correct? Because in the worst case time complexity, you are interested in finding out what will be the situation where I'll have maximum time consumed, right? In the worst case. That is why you're having big O of n cube over here. Makes sense? So this is how you're representing big O of